Hello everybody, now Cheuk Ting Ho is going to tell us about polars versus pandas and what's the difference.
Yes, hello, I'm back. Hey, thank you for being here. I thought everybody go for lunch, so. Yeah, so again, like I said before, if you were here yesterday, the first slide of my slide deck is the most important slide because then you have the whole slide deck. You don't have to take pictures afterwards because there's the link and it's public. You can access it. Polars versus pandas. I hope you know what is, well, I mean, like, you know the bears, you know the polars, and pandas, technically, is it a bear? I think it is. Yeah, you know the bears, but, well, I think most people know about the library pandas, but may not heard about polars. So, yeah, what's the difference? What is it about? And also, you know, those are my, social media and stuff. You can follow me if you want, and tag me, take some picture of me or whatever, do whatever you like. And the mic keep dropping. I don't know what happened. Okay, I hope it's fine. Okay, so again, I'm Cheuk. If you haven't known me yet, then, I am contributing open source. I love open source. I organize a lot of events, including EuroPython, which happened in 2 weeks, and a bunch of other workshops and things like that, online events and stuff. I have served the EuroPython Society board before for 2 years, and then now I'm also a PSF fellow. I'm looking for my next role, so talk to me if you're interested in anything that I talk about. So anyway, also I have stickers. Yesterday nobody asked for my sticker, so please, if you like that cartoon version of me and my teddy bear, I do have that teddy bear. I can also show the picture of my teddy bear to you. But yeah, come to ask for stickers. It's very nice, trust me. Come and talk to me and ask for my sticker. Who know what Polar is? Not the bear, but the Python library. Who have installed Polars before? No? Okay, so maybe I have the right audience this time. Who is using Polars? I think if you haven't heard of it, then maybe you haven't installed and used it. So, but yeah, this is for you. So, for people who may heard about like Polars before, they may think that, oh, Polars, is it like a Pandas 2.0? It's just like, oh, Pandas, but more modern and better. No, it's not. It's actually technically a Rust library. So by the way, I'm learning Rust. So if you have already taken a picture of the first slide, you see I have a YouTube channel and I'm actually streaming myself learning Rust. So you can check from all the problem I have with the compiler and stuff, and scratch my head, and you can watch me struggle if you want. But Polars is actually a Rust library. It's written in Rust. It's actually not just available in Python. It's available in Rust. So you can do the same thing that I will show you today, but using Rust and also other languages. So yeah, it's actually has a Python API. That's why you can use it with your Python. So you can import it as a library and then use it in your Python code. But also, like I said, it's Rust, so it's native. You can use it in Rust, but also you can use it in JavaScript. I do believe you can use Nook to install it or something. So yeah, it's pretty cool. It's across language. So some people consider it a pandas alternative. So I just assume everybody know pandas. So who doesn't know pandas? Like haven't heard of pandas? Okay, who has used pandas and? Okay, good, okay. I'm a bit concerned. So yeah, some people may consider it's like, oh, it's a pandas alternative, so, maybe I can try replacing my pandas with polars, so, but why would you do that? But also, what's the sentiment about, people trying to use polars instead? So I will show you the advantage of using polars, and also the advantage of not using polars as well. So first of all, to understand why people kind of now there's have a little bit of buzzword thing. A lot of pandas developer actually talk about polars a lot. But why? Why are all this hype? Why people really like polars? And why Rust? Why I have a friend who said because I went to FOSDEM earlier this year, so FOSDEM is kind of the biggest European conference for all the open source things, so it's not just Python. But we have different dev rooms. So we have Python dev rooms, which like people like you and me will go there and go to listen to the Python talks and stuff. But there's also other languages, for example, Rust dev room. And my friend said, oh, you know, usually all these people who are presenting in the Python dev room, now they all go to the Rust dev room. I was like, what? People migrating to Rust? Why Rust? Why people like Rust so much? Yeah, we'll talk about that a bit later. Also, pandas is, the difference is not just like Rust and you know, and not Rust, right? Like, pandas is actually not a pure Python library. It's actually a wrapper of NumPy. So NumPy actually use a lot of C extension to do a lot of calculation for you. For example, this is a pandas data frame. I stole this picture from someone else, so you can look at their blog if you want to. So this is kind of like try to understand the internals of a pandas data frame. So a pandas data frame is actually consists of different data types. Most of the case, you have multiple data types in there. And so how it works is that for each data type actually is a NumPy array. So a lot of things you can do with like NumPy that is super fast, for example, like calculating the sum, calculating all this kind of statistical thing. With NumPy it's super fast. So Panda is kind of taking advantage of that. So things with Pandas is decently fast if you compare to doing it with a for loop and writing your own Python algorithm. Then because they're using NumPy and all this like ufunc in NumPy and things like that. So yeah, NumPy use a lot of precompiled C code. If you have go to GitHub, go to NumPy and spy on their source code, you see a lot of all these files. There's actually C code there. So back to Rust. Why the hype? Why like people think, oh, Rust maybe is better. It's like maybe it's better than C. And I was like, people. Yesterday I had a conversation with another speaker, and we talk about, oh, actually Rust is like C++. It's like kind of modern version of C, and it's like now it's up and coming. It's like Python, like maybe a few decades ago that people are now like paying attention to it, and so yeah, why? Because there's something different with Rust. It's also a kind of relatively low level language, not like low as like machine code, but of course like C level kind of low language, so Python sit on top. So Rust is actually kind of a memory safe language. That's usually if you go and talk to other people about Rust, usually you heard this a lot. It's like, oh, Rust is memory safe, So, well, because Rust itself has this very special ownership rule that you can't find it anywhere in other languages, as far as I know. So I don't want to. Well, first of all, I'm not a Rust expert. I'm just start learning it, so I won't tell you exactly like how, exactly how things work and all this stuff. But from my experience learning Rust, I struggle a lot because the compiler will tell me off a lot of times because I mess up with these rules. You shouldn't do this because then you can't compile your file. So anything that you can compile, because by the way, 2 step back. Rust is like C, so you have to compile it before you use it, which is very different from Python. Python, you can just like, you write code in Python, and then if your computer have Python, then it will work because Python is an interpreter. It's not like C or Rust. So C and Rust is like a language that you written in that language, and then you need a compiler for that language to make it into a machine code that your computer understands to be executed. So Rust has a compiler, and this compiler is very, very picky. it will tell you off if you break any of those rules that you're not supposed to break. So those rules are usually there like to make sure that things are safe, are not wrong. So yeah, if it compiles, it's probably safe. So that's the idea, and this is why Rust is praised a lot. And also, of course, like Rust, when I learned Rust, the book, we also talk about the performance and things. So the performance is also another concern why people like Rust as well. But yeah, anyway, so yeah, people love Rust, including myself. So yeah, yes, that's good. That's why there's a lot of hype about Rust. And also, I forgot to put in the slides, there's a library called Pio3. So that is actually a library that will compile. You can write a library in Rust, but with Pio3, you can compile it into a Python library that you can use. So it would generate that thin layer of Python API that turn your Rust project into a Python library that you could use in your other Python projects. So that's how Polars comes to be. So, okay. Maybe you don't care about this like implementation thing. Maybe you're a user, you just want to find a better tool for your like day-to-day data manipulation and things. So let's look at the similarities between Polars and Pandas. So both of them actually have similar terms of describing a data structure. So we would have, so in Pandas we have data frames, we have series. In Polars we also have data frames, also have series. So it's kind of, you know, you don't have to wrap your mind into other terms like what are you talking about and things. So they're both handling tabular data and they are, you know, kind of data frames. So Polars also have different data types, so it can also handle a whole bunch of different data types just like Pandas. For example, numerical values will have all these different type of integer. You know, in Pandas, a lot of time we just generate that integer, but actually you can specify of like how big is the integer, right? It's like int 32, int 64 and things like that. I think the default in Pandas is int 64. But yeah, of course, because Polars is written in Rust also like have a very specific, you know, numerical types. You can't just say, oh, integer. You have to specify saying like, is it a sign or unsigned integer 32 or something like that. So yeah, so that's why Polars also have these all set of different numerical data types. So they also have floats as well, just like your Pandas data frame. You can specify it to be float, and then you can also specify, if you want, you can also specify the size of your floating point variables. So, so that's the numerical value. There's also like datetime. In Polars, there's also datetime object. It can handle datetime object, and it works very similar as those in Pandas. And objects, you know, who know what object is when you have a Pandas data frame and the column is object type? Who know what that is? Shout. No guess. Yes? Strings, yes, it's a text, it's strings. So yeah, Polars also have object types, and you can guess it's probably strings. Yeah, so good. So in Polars, you can also carry out data transformations. You can do all these things that we love to do in Pandas, like joins, privates, group by, and aggregate. So a lot of times you do group by, and then you will do some aggregation after that as well. So they're pretty much similar. So if you using Pandas, you won't find using Polars very different and very difficult to understand. So, but they are different, so how do I transition from Pandas to Polars? No, you don't. Sorry about that. There are things that are actually only available in Pandas, and I think at the end, I would suggest when do you use which one. Pandas is still very useful, I think, and Polars is just an alternative. So you can look into using it for some cases, for some certain tasks. Polars is like performing way better, but I will talk about all these later when I talk about the performance. So this is the section, I call it, if you do this in Pandas, do that in Polars, because I'm comparing the two. So Pandas, you import Pandas as PD. Polars, I think if you read the documentation, it's like import Polars as PL. So it's, you know, you can import, technically, you can import Pandas as a panda emoji, but who would do that? I mean, like, we are lazy, we just want to type 2 characters. So Polars, you can use PL. I think that's, again, that's what most people do and most people will understand. Pandas, you can read a CSV, no problem. Polars, you can also use pl.read CSV. You can also write CSV as well. So read CSV, write CSV, available in both. Pandas, because recently I'm just like teaching some people about using Pandas, and what they're interested in is to read some Excel file. So Pandas, you can read Excel file. There's actually a method you can use. It will call another driver. The internal is a bit complicated because Excel is complicated, but the API in Pandas is quite simple. You just read Excel and then put down some parameters like the name of the file, maybe which specific spreadsheet you want to import. But Polars doesn't have that. Polars support CSV, Parquet, I think, and another one I forgot. or maybe SQL or something like that. I forgot about that. Check the documentation. So pandas, sometimes, I've experienced that a lot when I was a data scientist. The files are too big, or maybe even you can fit it in memory. You don't want to handle them all at once. Like if it's a super big CSV file, and if you don't have to handle them all at once, you can read in batches. It's way friendlier to your computer, because you may blow up your computer, like if you are, for example, joining something, and then it's not the best choice for pandas. So but if the task can be handled by batches, maybe not joined, but some other tasks, then maybe you can do that in batches. Polars, we have this mechanism called lazy loading. So there are a few points that you can do lazy loading. For example, you can use scan CSV instead of read CSV. That will also do something similar to pandas, which is like reading them in batches. This kept falling, that's why I was, but okay. Polars, you can lazy load. You can also lazy load your transformation thing. For example, you are doing a pivot table, and then you're doing some group by and aggregate, very complicated thing. You can also do it lazily, and then collect them at the end. So that may actually also improve your performance. So this lazy mechanism is kind of also where Polars is super powerful. So. And then pandas data frame is like that. You can put in a dictionary, Python dictionary, become a pandas data frame. Polars works very similarly. It's also you have the oops, thank you. Yeah. So Polars also have this. You can put in a dictionary and it will become a data frame kind of thing. So this you can very easily translate. Just replace PL. It's very simple. But we'll see more differences soon. So pandas, we have these .head. You can see the first five line of rows of data. If you put in an integer inside head, you can control, like maybe I don't want to see 5, I want to see 10, then you can do that as well. Polars, there's no head, but you can use limit. So limit, if you put limit 5, that's basically the same as the default of pandas, df.head. So it works similarly, but I still haven't figured out how to read the last 5 entries in Polars. Like pandas, you can use .tail. So if you know how to read the last 5, then let me know. Maybe put in the minus a negative integer, but I don't know. I have to still check it out. So pandas, there's the major difference is how do you select a column. So a column is in pandas, you can do the square bracket thing, which is like indexing, and some people don't like this, but I think for me, when I'm teaching beginners, it's quite straightforward things to think about. You just square bracket and then put in the column names, and then if you are selecting multiple columns, then you put in a list of columns, which is the double square bracket underneath. But there's some trick in it, right? Like if you're a Panda user, you understand that, like, oh, you can also put in a list of one column, then it will turn out have a data frame. But if you use the just square bracket and then one column name there, that it will be a series. So it's a bit confusing. But in Polars, you can is less confusing in this way, because if you call a specific column, oh, by the way, pandas, you can also like df dot the column name, but people don't like it because column names can have a space in it, and then they will not be okay with the Python syntax. So for Polars, you call pl dot call, so that would give you back a column by putting in a column name. You can also put in multiple columns in there as well, but this method is specifically only for selecting columns. So for example, the second example here, you can see that if I call pl.call and I have a list of column names, and I put it in df.select, that will be the same effect as doing the square bracket thing. You will end up having a data frame by only having those columns that you specify in the parameters of select. So this is a little bit different how the two works. Another thing that's different is, like, we talk about the indexing of the column, but now it's like indexing of the rows. So pandas, we can do this filtering by, for example, I specify a column which is the Titanic age, and if it's bigger than 35, then that is the condition. So I would basically have a list of true or false, and I put it into the indexing in the Titanic here, then you would get, you can filter out all those rows that age is not bigger than 35. So in Polars, we have two. So in Pandas, we have square bracket for everything, right? But in Polars, there's two. So for columns, you do select. For rows, you do filter. So I think there's another thing that's like the clarity of which way you're doing the selecting, which I kind of like. It's more clear, like, because again, like when you teach beginner, it's very easy for them to like, oh, understand this selecting column. But once you, after that, and you, okay, now you do filtering, and they got super confused. It's like, why am I doing, But if you have two different methods, then it's easier to explain that, oh, now we are doing like columns, but then like now we are doing rows, so there's two different things. So another thing that Pandas had is, I don't know whether you have used it a lot, is df.plot. It's quite convenient because it will generate a matplotlib plot for you automatically. Even if you put nothing inside, it will probably be a line graph or something. It's try to guess what you're trying to do. So give you some visualization of your data frame very easily. Of course, you can also change the parameters, like kind of control how it got represented. You can also change the plot type. So if you don't like line plot, you can put it in someone else. And so it's quite powerful. It's already generate a bunch of plots that could be quite useful to understand the data for you. So for me, I think that's why Pandas is better for like data exploration. When you have some data, you just want to have a quick look about what's inside and understand more about data. And so Pandas is there for you. Also, Pandas, you can also like get all the statistical information very quickly as well. I forgot to put it there, but it's also something you could do very quickly with Pandas. Polars, no, there's no dot plot. No, you can't plot it with the Polars. Polars is only doing one thing and one thing well, which is data transformation. Pandas also have these, so someone so that's why follow me on social media. Someone tell me that they are trying to do this sampling because they want to recreate another data by sampling the real data that this person has. So Pandas had this .sample method that you could easily sample according to the data that you have, so it kind of create the same kind of distribution and things like that. But Polars doesn't have it. I mean, like if you want to implement it yourself, it's not too difficult, but you can just do it very simple. Like if you are a data scientist, you just want to quickly generate some statistic from your data, then Polars may not be your first choice. So, but then like, oh, Pandas can do so many things. Why do I use Polars? The key lies to performance. So unfortunately, I don't have, when I'm preparing the talk, I don't have time to do my experiment and stuff, so it's not very original. I'm going to steal someone's result. So this is actually a talk in PyCon.de. The recording is available, so if you have time at home, you can go watch it. Thomas is his name, this speaker. So Thomas has used Polars in his project in the past and try to show the different performance comparison. So this is some like cell data. So this is so he's running it. If you see this very small line here, he's running it on his own laptop. There's 8 core, which now modern day laptop is usually 8 core, and with 60 gigabyte of memory, very standard spec. And this is what the result gets. And then you can see, so because the height is actually the time, so the taller it is, the longer time it takes, so it's slower. So you can see that like with Pandas pi arrow is quite slow, and then Pandas numpy is decent but still slow compared to Polars. Polars, if you use the lazy loading and lazy collecting afterward in this mechanism, then it's quite fast. But usually lazy is also faster than eager, which is like don't use this lazy mechanism. But he said that because of some setting that he's manually limiting the loaded columns, that's why these two doesn't show a difference between the two, and sometimes lazy is even slower. But still, if you look at Polars and Pandas, Polars is faster, right, in performance. But this is not the end of the story, because if you are a professional data scientist, if your client provide you money and resources, of course, sometimes you may want to run it in a more powerful machine. So this is a 72-core cluster somewhere in the cloud, I believe. So 10 times difference of performance, more like, yeah, or even more than 10 times, because this is like 21 seconds, 22 seconds, and then, but if you use Polar Lazy, it's like 2 seconds. Well, yeah, 10 times, like 2 seconds if you round it up. So, yeah, 10 times difference, like 10 times faster if you use Polar's Lazy mechanism. So, so performance is something that would maybe kind of make you want to try to use Polars. So let's summarize. Like, which one should I use? Now I learned both. Which one should I use? So I would say that, this is my opinion, by the way. You can disagree and talk to me afterward and let me know. Pandas is very good for, do a lot of things, has a lot of function and can do a lot of things. So it's kind of like a Swiss Army knife. But you can't use a Swiss Army knife for, like a chef won't use a Swiss Army knife to cut, let's say, sashimi or something like that, right? A sushi chef will use the knife designed for cutting sushi. So, so it is kind of like a more general purpose thing. Polars is specialized, I think, so far from what I see, is for data transformation. It's super fast, and it provides very good method for doing that. Pandas they have, like, now, mainly the trouble is that if you have something that's out of memory, you can't use Pandas. Maybe you have to look into something like Dask or things like that. But yeah, usually if your data doesn't fit in the memory, don't use Pandas. Even your data is barely fit into the memory, you may have to consider twice. Polars, now they have say that they have this capability to handle out of memory data by like streaming them. You can have a lot of this lazy loading and things. But according to Thomas, who gave the talk, it's very tricky. It's still in alpha. It's not very stable. So maybe now it's better after a few months, because like Polar is very fast developing. So maybe now it's better. I don't know. Try it yourself. Pandas, again, like on contrast, is a very stable, mature project. It has been here for a long time. So, everybody knows about it. And now, like, if you talk to the core team, they said, like, oh, actually, now there isn't a lot of very easy fix issue because they have all been fixed. So, yeah, it's a very mature project. For Polars, if you, for example, like me, learning Rust, and you want to challenge yourself, you can have a look. Maybe you find something to work on. Like, it's a young, very actively developing project. The maintainers are great. They are very responsive. And there's a community that, like, for users and developers, you can go there and talk to them. On Discord, not in person, on Discord. So you will find that out in their website. So Pandas, I think, again, is very good for data exploration. If you don't understand the data is something that got sent to you that's new, you can maybe take a sample of those data that you receive and have a look of them and do some statistical analysis, do some visualization. Then, yeah, Pandas is good for that. But when you are ready for production, when part of your pipeline is to do some data transformation, maybe you can use Polars to boost the performance and make it quicker, because now you're handling a bunch of data. So that may be better for you. But again, it's a very young project. So if you have written some code, make sure you pin the version, because they may change quite a lot very quickly. So I want to show you this picture. So this picture is a few months ago actually, is it last month? I think it's last month. It feels like a long time ago. But yeah, it was in PyCon Lithuania. So that, like, so I'm here. So on my right-hand side is the Pandas maintainer, the release manager, so Mark Glacia, he's my good friend. And on my left-hand side is Richie, and he's the creator of Polars. So you can see that, like, that's my new friend, that's my old friend, we are all friends, and we are not competing each other. That's beautiful thing about open source is, like, we are learning from each other and we are collaborating. So don't feel that you have to use one or the other, or you have to be in one camp rather than the other. Use both, like, depending on your use case, it's fine, But if you haven't tried Polars, I think you should give it a try. You should see if it helps you in some of your projects. And that's the end of my talk. Again, I've told you yesterday already, EuroPython, last time to buy the regular price ticket, do it today. And yeah, don't wait. if you can't really travel in July, there's another chance to visit Prague in September. And I think they just closed the CFP, but that means that the speaker lineup is going to be announced soon. So yeah, thank you.
Great, thank you very much. We have, yeah.
No, it's fine.
Yeah, we have two questions
Yes.
right now. And the first one is, Polars looks a bit like PySpark. What's the difference?
Ooh, PySpark. Yes, PySpark is Spark. It's not written in Rust. I think PySpark, I may be wrong because I haven't used it that much personally. I think it's more for like streaming data. It's not exactly the same. So again, it depends on your use case. If you have some stream of data, then pick something that can stream your data. But Polars is designed to do data transformation, but like in a very fast manner and performance and memory safe manner.
Okay, so somebody asked the kind of question like, we checked during your talk, and other than plot, all is implemented in Polars, sample, head, tail.
Oh wow, now it's there. Okay, maybe I'm a bit
Yeah.
outdated. Yeah, thank you for clarifying that. Yeah, that's good. That's good news for Pandas users. Thank you.
Yeah, and I think we don't have any more questions. Thank you very much for the talk
Yeah,
and
thank you.
for answering the questions.